Hello everyone, we are Team Wuhan Hunter Squad from REVA University presenting to you a project Wang Reda. Wang Reda is an inter-platform conversational robot which was mainly built to check if people are adhering to the social distancing policies set by the government or not. COVID has been a severely struck pandemic and until a proper solution is found for the same, it is necessary for the people to adhere by its rules. And our projects help with the same by these three main components. Firstly, the video checks if people are following the social distancing policies or not. Secondly, the audio wherein the people can converse with the robot with respect to the queries and questions related to COVID and other similar instances. And also people can report a suspect to it. Thirdly, our dashboard wherein a user can log in and have access to their personal user database, and wherein people can check for the report of suspects, and also to the dashboard wherein the photos for the same is available. Now let's look into all these three.
A remote SQL database is set up to store all the information reported by both users and the bot. This data is reported and mapped back onto the website, which gives users an access to the information. The website login page is handled by Auth0, which ensures that only authenticated users get access to the information. The website has all its information stored in terms of visual analytics like graphs, images and tables, which helps in better understanding. There is a table on the website which records and reports all the suspects reported by the users. This table can be used by the users to check if there are any suspects near them. The gallery in the website stores the information of the images reported by the bot of people showing that they are violating the physical distancing. The histogram on the website shows the number of physical distancing violations recorded by the bot every day.
So basically, how does our project work? To be very simple to say, a robot will be placed inside a corridor or inside somewhere like a near school office or anywhere, but it should be indoor. A robot will be capturing the image and processing it. If there is any physical distancing happening, when there is a physical distancing happening, a robot will be sent near to the person and it will yell at them, please move away. If they still do not move away, our robot is going to capture the image and upload it to the server, and also our robot will count the number of times physical distancing has been violated.
Recent innovations and advancements have proven that speech recognition is one of the most easiest and interactive way you can speak to a machine. Thanks to Python API and advanced speech recognition, we are able to get accurate information from user and interpret what the user is trying to tell irrespective of the region they are in India. Google's Google Cloud Platform and Dialogflow APIs allows us to have instant query identification and action deployment, which allows us to interact with the user with almost no lag. Speaking to Reda is very easy. Head over to any of the machine deployed in your area and say wake up or hello Reda. If you do not have any machine in your area, your phone is more than enough. Just take out your phone and open Google Assistant and say talk to Reda Assist. You will be directly connected to our servers wherein you can speak to the Reda's voice assistant. A few questions which you can ask Reda are about COVID statistical information and how to stay safe and all the advancements that is going on currently about COVID. You can also report a suspect to Reda, and also that will be stored into our database management seamlessly. The reported suspect data is forwarded then to our authorities wherein they can view and take further actions necessary. You can also view the same in your dashboard. Speaking with Reda through your phone or through a machine is also very fun. It can answer to almost all of your basic questions and also be very funny at the same time. Now let us see how this functions.
The tech stack we have used in our project is hardware such as Raspberry Pi, web camera and speakers and microphones. For the software part, we have used Python, OpenCV, YOLO and speech recognition modules, and we have used Flask, MySQL database and HTML, CSS, JavaScript for the front-end part. And the cloud services we have used is Dialogflow and Azure and Heroku. And we have used Auth0 for the authentication process, and it was actually a side competition as well in the hackathon. Therefore, we even we also needed a strong authentication for the administrator usage. Therefore, we made use of Auth0 for the authentication process.
As you can see here, we have used the YOLO v3 algorithm for our project to find the physical distancing. How we are going to do is, we are going to apply a single neural network to the complete image and find the bounding boxes. How we are finding the bounding boxes are, single neural network when applied to the image will divide the image into the regions, and and these regions are obtained by the bounding boxes and the predicted classes. So depending upon the probability of the predicted classes, we are going to find whether the person is human or not. As you can see here, we have made some calculations to find the Euclidean distance. So if the distance between the bounding boxes is lesser than the particular value, so and physical distancing is violated, therefore robot will move to the person and yell at them to move away. If they don't move away, then it is going to capture the image after some time. If they still persist to, if they still keep on violating, it is going to capture the image and report it to the administrator through HTTP protocol to the server. And also it keeps a track of the count, how many times per day physical distancing is being violated. Therefore through using that data, we can have an analyzation like how much the awareness have been created in the society and created by the robot.
Bad, very bad. I should definitely report about your activity to my master. I may have to do it, if you don't move away from each other.
Firstly, let us see as to how the speech script works. We can see that we have imported certain packages, functions, and APIs. This allows us to make Reda truly cloud dependent so that it can run seamlessly from anywhere, anytime. Initially, Reda does not reply to one of the user's query. It would be in sleep mode. Only when the user would send a wake up command such as hello Reda or hi, or it would start listening to the conversation. This feature was made to promote privacy and dependency. It does not listen to the user until these commands are executed. Once the wake-up call is given, Reda starts to listen to the queries and starts to understand the speech using speech recognition API through cloud. The data is then transferred to Dialogflow, where the intent query matching is executed and the output action is deployed. The output is then relayed back to the script, which is then converted as a speech and shown to the user. Not just that, the suspect information is also stored in the database onto the dashboard so that the authority can view and take necessary action as required. This was the multiprocessing functions which we wrote, which allows us to call the Google Dialogflow using the required credentials and reply back to us seamlessly with almost no lag. Not just that, none of the speech conversed through Reda and the user is stored unless which is absolutely necessary. For example, only queries such as suspects is stored. Other queries are not stored in order to promote privacy. Now let's see the working of it. If at all this program was run on any mobile device or a platform or any operating system such as Raspberry Pi which would support the robot, this is how it would perform. Firstly, the speech script would be running. This would be the welcome message for the same. But now it's inactive, so we need to turn on by giving the wake up command. Hello Reda. We can see that Reda wakes up and now it will listen to all of our commands.
You?
What can you do?
Hello there. I'm Reda, your coveted assistant. Here is a list of commands that you can perform using me. Safety tips, how to stay safe. Total cases. Recent world news.
As we can see,
How to
Reda is
prevent
able
it
to
spreading.
reply back to me.
What to do if you're sick. Precautions for
This
people
is
with
how it
higher
would reply
risk.
to the user when
Cope
spoken.
with COVID stress. Immigrants' information and
We
support.
can see the query and intent,
Preparing for a disaster.
confidence.
Report a suspect.
This basically runs on a machine learning platform. Report a suspect.
We will be needing some information about this suspect. Kindly do enter them accordingly. Do you know them personally / have you come in contact with them anytime recently? Reply with yes or no.
Yes.
Alright. What is their name?
James. Paul. We can see that the SQL collection mode has started.
Provide us the address of how we can see the SQL connection not. What's their age? Reply null if unknown.
18.
We have stored that their age is 18. Do they have any visible symptoms?
No.
Symptom. No recorded. The details will be forwarded onto our dashboard and relevant authorities. Thanks for informing.
You're welcome.
You're so polite.
Now as we can see, it is uploaded back to our server. So this is how it would perform. And
Sorry, I didn't get
yes,
that.
it's still listening to
Can
us.
you rephrase?
And
For a
until the
list of
program is closed, it would continuously speak back to us. So this was the speech script which runs on Reda. A small demonstration of how Reda Assist can be called through your Google Assistant. Simply open your Google Assistant and talk to Reda Assist.
Let's get the test version of Reda Assist.
Hello, I'm Reda, your COVID assistant. How can I help you? For more information on my functionality, reply with what can you do?
What can you do?
Hello there, I'm Reda, your COVID assistant.
I shall skip through this, but as you saw, we can use Reda Assist even on our phones seamlessly without having any issues. This way, Reda can be used even when we are away or when robot is not accessible. Through this also we can report suspects, which is a really good thing.
So as you all see, this is the homepage of Wang Reda. It consists of some important features and code samples of Wang Reda, along with what it does and what it is. It also consists of a gallery which shows some sample output images of our bot and also the team details. So on the top right corner there is a login button. Once the user clicks on the login button, they are redirected to an authentication page where they will have to log in. For this authentication, Auth0 is being used. Auth0 is a flexible drop-in solution to add authentication and authorization services to our application. Auth0 will link the user's Google account to log in the website. So once the user is logged in with their Google account, they are redirected to a dashboard. The dashboard basically consists of simple FAQs which are oftenly asked about the pandemic or physical distancing. So this gives the users a basic idea about what is the importance of physical distancing and of what extent is the pandemic and how seriously should it be taken. So as you can see, there is a side menu bar and there is demography in that. Demography is just a histogram. A histogram showing the number of physical distancing violations, which is counted by the bot. The bot updates the number of physical distance violation recorded into a database, and that database redirects all the data back here to the histogram. Let us check the database. So this is my local SQL database, and as you see, this is the reported data by the bot. So it reports both the date and the count on the particular day. So whenever it finds that there is a new violation, the count is incremented by the violations count it has recorded. And the same thing is reflected back here in the histogram. Coming to the next, data compendium. Data compendium is a table. It consists of all the suspects reported till date by the users using the assist. Whenever a user reports a suspect, the assist reports the data to a database, and that database is linked with this table of reports, which then updates it here. So let us check the database. So this is the table corresponding to the suspects reported. It shows the serial number, the name, symptoms suffered by the suspects, the address of the suspects, age, and the date of reporting. So the same thing is reflected here on the website. So using this, the users can actually become warned about if there are any suspects around them and be cautious with more physical distancing and following the norms. Gallery. Gallery shows the images captured by the bot whenever it encountered a physical distancing violation. So whenever there is a physical distancing violation, it takes the picture and updates it here saying that there was violation in physical distancing. And then on the top right corner, you can see that the username is displayed along with their name, and you have options like profile settings and logout. The user can log out of the website using this. Thank you.
This might not be an accurate representation, but this is how the mini robot would have functioned somewhat if we had our hands on the right components. This was our first prototype wherein the robot was initially called as an obstacles avoidance robot, which had the capability to detect and detect the surrounding objects and maneuver it to its destination. It was simple, accurate, cheap, the battery was long-lasting, and inbuilt with various sensors to detect the scenarios. It was an interesting concept, and with a slight modification in its coding, we currently can able to hook it up to our mainframe program. We hope to try it out once we get back to college, and we are interested to see how things would turn out.
Faced while we were working on the project. Our Raspberry Pi broke down. We tried several attempts to reboot it up, but we couldn't do it because of some hardware issue. And remote working was also one of the major issue for us because our teammates are in different parts of the India. And still we made up our mind and we finished the project on time. We have done our Flask application on localhost, but because of the lack of knowledge of using cloud services such as Azure or Heroku, we couldn't successfully deploy it on the Flask part on the server. And training of the Dialogflow took a little time, but still we finished it off because we, the team of 3, divided the tasks as per the plan.
Wang Reda is a simple yet a powerful solution, which is more concerned towards giving awareness about the importance of physical distancing and help the users maintain their health. This model can be implemented on an SBC as a robot and placed at schools, colleges, hospitals, offices, grocery stores and anywhere where there is a manageable crowd. As this is not just a robot and can assess the users regarding any queries about the pandemic and help them report the suspects near them, it turns out to be very useful for the government officials to track the community spread. Thank you.